Hey folks, it's Mr. Carter here, ready to do Homelink 2.5. Again, put your name on the sheet if you haven't yet. Alright, so we're going to be working with prime and composite numbers. Well, a prime number is a number, a whole number that has exactly two different factors, one and itself. A composite number is a whole number that has more than two different factors. So the directions are, for each number, list all its factors, write whether the number is prime or composite, and then circle all the factors that are prime numbers. So if I'm looking at the number 11, the factors for 11 are 1 and 11. Because you can't go 2 times anything to get 11, or 3 or 4, and so on and so on. So the only factors for 11 are 1 and 11. So this makes it a prime number. And the factors that are prime in this case are 11. So if I'm looking at 19, again, my factors are 1 and 19. That's the only way to get 19 is 1 times 19. So again, that makes it prime. And the only factor that is a prime number is 19, so you're going to circle it. When I'm looking at 24, there are many factors for 24, so we're going to start with 1, and I'm going to go down here and go 24. Then I'm going to ask myself, okay, 2 times anything, and the answer is yes, 2 times 12. So I'm going to put 12 down here. I'm going to ask myself, does 3 times anything equal 24? And the answer to that is yes. 3 times 8. I'm going to ask myself, does 4 times anything equal 24? And the answer to that is yes, so it's 4 times 6. And then I ask myself, does 5 times anything equal 24? And the answer to that is no. Then I'm going to say, all right, does 6 times anything equal 24? Yeah, and we already have 6 times 4. So that's where we know we have all our factors. So because it has more than one factor, this is 24 is a composite number. So we're going to write composite here. Okay, and if we're going to go back and we're going to look through all our numbers to see if there are any factors that are prime numbers. So 1 is not a prime number, but 2 is, because the only thing that you can get 2 with is 2 times 1. 3 is a prime number. 4 is not prime because you can go 1 times 4 and 2 times 2. And that is it. The rest are composite numbers. Okay, so for 29, 1 and 29 only, that makes it a prime number. And the factor 29 is a prime number. Okay, 36. So I'm going to go 1. There are quite a few numbers that are factors. So I'm going to go 1, and I'm going to do just like I did for 24. I'm going to go 1 to 36, put it way at the end of my list. I'm going to ask myself, does 2 times anything equal 24? The answer to that is yes. That would be 18. About 3 times anything? Yep. 3 and 12 equal 36. 3 times 12 is 36. How about 4 times anything? Yep. 4 and 9. If you go 4 times 9, you'll get 36. How about 5? 5 times nothing will get you 36. So 5 is not a factor. How about 6? Yep. 6 times 6 is equal to 36. Then I go to 7 times anything equal 36. The answer to that is no. About 8 times 36? No. About 9 times 36? Yep. 9 times 4. So we already have 9 down here. So that way we know, now we know we have all our factors. So that means we're done writing our factors. So this is definitely a composite. I'm going to write that. So now we're going to go through and figure out which of our factors are prime. Well, we know that 2 is a prime number, 3 is a prime number, but none of these other numbers are prime. Okay, so I'm going to have you do 6, 7, 8, and 9 by yourself. Just want to see how you do, and we're going to go over them in class tomorrow. But just to give you a hint, the rest of these are composites, so that means they're no longer prime numbers. So there will be more than 2 factors, so that's just a hint. And you can go with that. All right, so at the bottom there's some practice, there's some adding problems, and a couple of subtracting problems. I'm going to do them on a scrap paper, so we can go through them. Number 10, I stack them vertically because that's easier for me to add or subtract. So for number 10, we're adding 841 to 527, so 7 plus 1 is 8. 4 plus 2 is 6. And 5 plus 3 is 13, so it's a 3 in the hundreds place, and that would make it 1,368. Write that in there, 1,368. Okay, number 11 is 3,263 plus 5,059, so 9 plus 3 is 12. Put a 2 in ones place, carry the 1. 6 plus 1 is 7. 7 plus 5 is also 12. Put another 2 in tens place, carry the 1 over. 2 plus 1 is plus 0 is 3. No carrying over there. And 5 times plus 3 is 8. So the answer there is 8,322. So I'm going to transfer my answer over. 8,322. I'm going to let you do 12 on your own. It's another adding problem. I do want to go through some subtraction with you. Number 13 is asking 4,100, or it's asking what equals 4,172 take away 3,236. So again, I stacked my numbers. 2 take away 6, you are not able to do that, so you got to do some trading. So we're going to trade 110, make it a 6, into 10 ones. That now becomes 12 because we already had 2 ones there. 12 take away 6 is 6. 6 take away 3 in our tens place. We can do that without having to trade. So that would be 3. 1 take away 2, we are not able to do that. So we need to trade from the thousands place. So we trade 1,000s, that would be 3. We already have 100, that'll make it 11. 11 take away 2 is 9. So our answer there, and 3 take away 3 is 0. So our answer there is 936. Number 14 is a little tricky because it's asking you 8,158 equals 5,071 plus what? So we have to ask ourselves, how do we solve this problem? Well, we solve it by going 5,071 take away, or take that away from 8,158, and you'll get your answer. Okay, so over here, I stack the numbers 8,158 take away 5,071, and that'll give us our answer. So 8 take away 1 is 7. 5 take away 7, we can't do that. We have to trade. So we're going to go here. Trade that 1. There'll be none left. This now becomes 15 tens. 15 take away 7 is 8. 0 take away 0 is 0. And 8 take away 5 is 3. So our answer is 3,087. So I'm going to go ahead and transfer that over. 3,087. and 87. And you can check your work by going to see if it's right. So 5,071 plus 3,087, if you add those two together, you should get that number of 8,158. All right, so 15 is a traditional subtraction problem, so I'm going to have you figure that out on your own, and we'll go over it in class tomorrow. But if you have any other questions, please feel free to come see me, and I will help you, and hope you have a good day. Thanks.